Okay, welcome everybody, and welcome to what we call vectors and scalars. This is going to form the foundation of what we call dynamics in physics. So this is the bedrock of paper 1 that we're going to be looking at in this, vectors and scalars. Okay, without wasting of time, let's begin. Quite some notes to write. Now, we're going to, in physics, we talk about physical quantities. So when we talk about vectors and scalars both of them are called physical quantities. So all variables in physics are divided into these two. Physical quantities are divided into two. Okay, can I just redo my note? I know you probably have written this, but it's the same thing. I just wanted to look a bit different. So I have my physical quantities, and they are divided into two. We call them scalar quantities and vector quantities. We are going to now go into the definition. So we start with scalar quantities. What are scalar quantities? Remember, the key word is that we said that they are physical quantities. So we say these are physical quantities that have magnitude only. Magnitude means size only. Example, time. If I say time in physics, we measure it in seconds. All right, so time, 5 seconds. You see, it's just a number. The word magnitude refers to a number. Let's put that. The word magnitude refers to what? A number. So it's a number and just a unit. You would get to see a bit more. Example is time. Another example is height, which is measured in meters. So for example, how tall are you? You are 1.7 meters tall, height. Another example is speed. Please, the units are very, very important. Meters per second. And we always write it as m.s to the power of -1. How fast is a car traveling? A car is traveling at 20 meters per second. So these are examples of scalar quantities. They only have magnitude, and magnitude is number. They only have magnitude. This means that they are, let me give you another one, sorry. Distance. Distance is also measured in meters, right? Which means that they are always positive. This is very important. They are always positive. So all of these things that I wrote will forever be positive. And I want you to note these examples that I have given you. It talks about quantities that contain magnitude only. We'll see the difference now. Vector quantities. These are physical quantities. Remember, keep the definition right. That have both magnitude and direction. You see now, this has two things. It has magnitude and direction. Example is a force. If I talk about a force, which is a push or a pull, look at that. If I am pushing, the direction is away. If I am pulling, it's towards. Can you see the direction now, right? And our unit is in newtons. Plus direction. Example, pushing with 5 newtons east, or 5 newtons right, 5 newtons left. It doesn't matter. Just an example, 5 newtons left. You would notice that that would represent the magnitude and that would represent the direction. There must be direction there. Example 2, displacement. We are going to define all of this later on. Displacement is meters plus direction. So we're talking about something like 5 meters to the west. This actually talks about, I'm going to go into it later, location. We'll go into it later. Number 3, speed. No, velocity. It is meters per second, just like speed, but there is direction to this time. And number 4, for our sake of study, acceleration. This is meters per second squared. So I'm using quantities that we would use over and over again. So I've listed 8 quantities. We need to master which one is scalar. I've given you 4 scalar. I've given you 4 vector. An example of force is weight. Weight is an example of force. So we have, let's add push, pull. Another example is weight, still under force, the weight of an object. So I have 4 examples. I have time, I have height, I have distance, and I have speed under scalar. Under vector, I have force, displacement, velocity, and acceleration. All of these are things that we are going to look into one by one. So I have chosen these examples because they form the bedrock of our study. Time, height, speed, distance. Please, those examples are so important. You need to know them. Force, displacement, velocity, acceleration. So a vector quantity has both magnitude and direction. Let me know if we are ready to move. All right, Junior, Google. Naran, are we done writing? Hi, Emmanuel. Emmanuel, you need to quickly take a screenshot. Because I'm about to move to the next page. So, Emmanuel, we said there are 2 types of quantities in physics. Scalar and vector. Scalar, magnitude only. Vector has both magnitude and direction. And I've given very precise examples. Emmanuel, do you have a picture? So we can move on together. All right. So guys, we're going to look at all of this again. So our major focus would be on vector quantities. Vector quantities are represented by arrows. So every time we want to represent a vector quantity, we use an arrow. Where the tail That's the tail. It represents the magnitude. Remember what magnitude is? It's the size. So the bigger the magnitude, the longer the tail. The longer the tail. And the arrow head, however, you can see that actually represents my direction. So you would notice our keywords, magnitude and direction. This is called the head. The head represents the direction and the tail represents the magnitude. Example, represent the following in vector arrows. 1, 5 newtons east. 2, 5 newtons west. 3, 7 newtons west. I'll guide you through all of this once you are done writing. Let me know once we are done. I want us to look at those vectors and represent them. I only got 1 thumbs up. Don't forget to let me know. Okay, we're good. So we have those forces. Right now, we're not going to do measurements. I'll be showing you how to use the measurement. We just want to answer quickly. Number 1. All right, so let's have a little compass on the side here. Okay, just, those little compasses that talks about the north, the south, the east, so we all agree, and the west. Okay. Am I right? Are we good, everybody? So that's our general compass that we'll be using. So if I say 5 newtons east, it means it must be pointing towards the right? So we're just going to represent, let's just do that for now. Now, that is 5 newtons what? East. If I say 5 newtons west, it's going to be the same length because they are both 5, but different direction. Now, if I say 7 newtons east, it's going to be in the same direction as this one, but longer. Number 1, number 2, and number 3. Does that make sense to you? Guys, let me know if that makes sense. You would see the first 2 are of same length, but different direction. Then number 2 and 3, same direction, different length. Let me know, guys. Talk to me, please. Did it make sense? Okay, so now we're going to talk about addition and subtraction of vectors. Vector directions, let's start with that statement quickly, are represented with either positive or negative based on choice. For example, if I say west is positive, then definitely east will be negative. E.g., if east is positive, then west will be negative. That's our first point. Number 1 there. Vector direction, vectors direction are represented. I missed the third. With either positive or negative based on choice. So you are allowed to choose. That's our first point. Can we continue? Okay, got a thumbs up there. I'm waiting for 2 more. All right, beautiful. So plus and minus. That's the thing we have to first do. Now, number 2. Number 2. When vectors are added, they become one vector known as resultant vector. So now the question will be, what is a resultant vector? A resultant vector is a single, very important, vector that has the combined effect of 2 or more vectors. A single vector that has the combined effect of 2 or more vectors. We're going to look at quick examples now. Find the resultant vector of the following set. vectors. Number one. So vectors, let's use forces this time just to quickly show something. F1. Let's say F1 is 3 newtons east and F2 is 6 newtons west. We want to find what the combined vector will be. Remember, we said we add, but please, we don't just add. We don't just add. So, my solution, and then you will do the second one for me. I have to choose. So let's choose east as positive. It means F1, which is east, becomes positive 3 newtons and F2 becomes negative 6 newtons. Why is it negative? Because it is opposite now in the other direction of east. Now, F resultant, which we are going to write as F res, will be equal to F1 plus, because we are adding, it's an addition, it's a sum. And what would that be? That would be 3 plus negative 6, which is what? Negative 3. Now, what does that mean? What is negative? We have to interpret that. Negative is what? West. So, our resultant force is 3 newtons west. Let me know if you are okay with that. The sign is very important. So I decided to choose east as positive. I'm going to switch my direction now for you to see. I chose east as positive. It means F1, anywhere I see east, I now take it as positive. So F1 is positive, 3. F2 is negative. Why? It is in west direction, which is opposite. Then I add, because it's an addition. If I have 3 forces, then I'll say F1 plus F2 plus F3. If I have 4, F1, F2, F3, F4. Did it make sense? Did it make sense? Do you think you have an idea? Let's see. Let's change the direction. Okay. Let's choose west as positive. Will this affect our answer? Now, F1, since F1 is 3 newtons east, it becomes negative 3 newtons, right? And F2 is 6 newtons west, it becomes positive. So, F res, which is F resultant, will be what? F1 plus, which is negative 3 plus 6. Now, what do you have? Positive 3. Remember what your positive represents? West. Oh, so my F resultant is what? 3 newtons west. If you notice, my answer is still the same. My answer is still what? The same. Talk to me if you are good. Talk to me if we are okay. Hi, Chief, you are? How are you, Nana?
I'm good.
I'm very well, thanks for asking. Okay, I'm going to make sure you catch this. Or have you done this at school?
No.
Okay, so we're talking about forces, right? And we're talking about vector quantities. The vector quantities are things that have both numbers and direction. So, for example, an example is force. So you would say I'm having 3 newtons. The 3 is the size, and that's the direction. So we're trying to add them together, but in physics, direction is always represented by plus or minus. So you would see, very straightforward, I chose east as plus. It means this one is a plus 3, and this one becomes what? A negative. Beautiful. Then we add together. Now, my answer is a negative. but we have to interpret that. Wait, this is negative, right? But we chose east as what?
Positive.
It means the negative would be what? West.
Yes.
And that's my answer there. I'll catch you up. You'll catch up now on our second example, okay?
Yes, sir.
All right. Okay, guys, here's another example. Before you start, you must give us that direction. So you can choose whichever one you want. All right. Let east be positive. You must mention that. It means my F1 is positive 7. My F2 is positive 8. And my F3 is negative what? 10. Addition, let's add all of them together so that we have a single value. What would that be? 7 plus 8 plus negative 10. And what would that give us? Positive 5. And what does that positive 5 tell you? We said positive is east. So it's going to be 5 newtons east. It must have magnitude and direction. Are we okay, everybody? I want to give you 2 questions to do for me. You got it, you feel all right?
Sir.
Okay, beautiful. Are we ready to move? Okay, Google, give me a thumbs down. You'll give me a thumbs up when you're ready, Google. Mandla and Junior and Chifua also, please. Chifua, are we moving? Okay, beautiful. Okay, you do this for me quickly. Just 2 questions. All right. 1 minute or so. I'm sure we can do that in 1 minute. Let's see. Lubanzi Makrina. Who am I speaking to there? Who's using that ID to log in? Are we done? Please type your answer in. Type your answers in for number. Okay, Google is still busy. Junior done. Nuran, are you done? Type your answers in for me, please. For number 3, just type 3. Type your answer in, and number 4, type your answer in quickly, please. Okay. Remember to put your unit. Emmanuel, you just wrote 9 West. Remember to put your answers in. Very, very important. Thank you, Nuran. I want more answers. Chifiwa, Google. Let's see if your answers are the same. Okay, let's mark now. Please, the unit is very important in physics. For the first one, since they are both west, let's just say let west be positive. It means F1 would be positive 3 plus positive 6, which is positive 9 newtons. And that is 9 newtons west. Straightforward, right? The second one, F1, okay, let north be positive. So I said F1, F resultant rather. Will be positive 8. Let's do it this way. Plus positive 3 plus negative 10. I hope that makes sense. My south is negative. 8 plus 3. Why are you guys giving me 5? Where did you guys get the 5 from? Oh, sorry, it's south. South. Okay, I'm wrong. Second one is south. But you guys are giving me 5. Where is the 5 from? Because there are 3 forces. Didn't I see your answer as well? I think I saw your answers. Let me go back. Yes, I'm right. Emmanuel, you gave me 5. Okay. Number 2, Chifiwa, you gave me 5. Yes, Gugu?
So mine is negative 5.
Negative 5, right? Okay, all right, no, I see now. But in which direction now will it be? I see now why you gave me 5. All right. So, negative 5, right? But what will that be? 5 newtons where? All right, your answer is correct. You gave me south. 5 newtons south. Google, are we on the same page? What's wrong, Google? Unmute yourself and talk to me.
So I got negative 5.
Yes, but I said we cannot leave our answer with what does the negative mean? The negatives represent a direction.
So is it okay if like it's negative or positive?
It must follow a negative is fine based on your direction, But you cannot leave your answer as a -5. What does your negative mean? Are you with me?
Yes, sir.
Okay, what is the challenge? You got -5, right?
Yes.
What direction did you pick?
South.
South as? Look at my first line, Gugu. What did you write here for yourself?
Oh, so I said let north be positive.
Yes. So your answer will be -5, right?
Yes, sir.
But we cannot leave our answer like this. We have to interpret what does the negative mean. If north is positive, then south would be what?
Negative.
That's why I have a south here. Are we on the same page now?
Yes, sir.
The negative means the south. Look at this one. We chose west as positive. My answer is positive, right? But I have to interpret what that plus is. Oh, plus is west. That's why I have a west there. Because it is a vector quantity which has both magnitude and direction. Are we okay?
Yes, sir.
All right, lovely. Now we can use, let's talk about something quickly before I talk about, yes, talk to me. I see a hand there. Yes, Emmanuel?
Why don't we just isn't it quicker to just say -3, like 3 plus 6 plus C plus C minus 8 plus 5 rounds? Isn't that like quicker? Or do I have to show this plus 8 minus 3 minus 7?
You have to. That's the order of physics, because we want to see the plus and the minus. Okay? Please show all your directions. Very, very important. Very, very important. Okay, let's use vector diagrams for vector diagrams. For resultant vector. That is, we want to represent all of this that we just did in a vector diagram. Example 1. F1, 5 newtons west, and F2 is 7 newtons east. What is our F resultant? I'm going to do the manual, then use the diagram. And I want to increase my pace a little now. Okay, so what do we need to do? Let's choose east as positive. We can do that. So F resultant becomes, since east is positive, you notice my F1 is west. -5 plus +7, and my answer is +2, which means 2 newtons what? East. But I want to do that with a diagram. Look at how I'm going to do it. And then we will learn to use construction as well. Okay, look at this. This is the east one. That's the west one. Now, the remaining, what is short? Okay, I want to quickly explain something. I should have given you a note to say, okay, I'll explain after this. All right, guys, look at what I have. Everybody, please stop writing for the moment. I have 7 to the east. That's fine. And I have 5 to the west. You notice I'm starting where that one ended. I'll be telling you what that means just in a moment. The question now is, what is going to be my resultant? Please watch this. Do you notice that this is the tail here, and this is the head. If I want to draw my resultant, I'll have to, you see where the tail is? It means the tail must be at the end and the head must be here. I'll explain again. You see, this point is the head and this point is the tail. So it means my tail must be here and the head must be there. So it's facing that direction. And it makes a lot of sense because my resultant is 2 Newton what? East. Did that make sense a bit? Before I give you a note. Did that make sense? Just a little bit. We'll do a few more. We use tail to head method to show the resultant vector. The open tail will represent the tail and the open head represents the head of the resultant vector. Okay, let's push quickly. Look at examples. I want to go into a few physics concepts of motion now. Give me a thumbs up when you're done. Naran, let me know. Okay, let's look at a few examples now of how we use the tail and the head diagram to find the resultant. Okay, thanks, Nuran. Okay, let's look at examples. So what we do is we join the tail usually to the head. Let's look at a few examples. F1 equals to 3. Okay, guys, I'm going to combine two things here. All right, 3 newtons east and F2 is 6 Newton east. Now, if I want to use construction, I'm combining using construction as well. We can say let 1 Newton be 1 centimeter. Okay, I'm combining two things now, so understand what I'm doing. Let 1 unit, 1 centimeter, it means for F1, I'll be measuring 3 centimeters using my ruler. And for F2, I'll be measuring 6 centimeters. I hope that makes sense. Because I'm saying let 1 Newton be 1 centimeter. But that's not the key thing. What's important is how we do it. So I will take my ruler and measure 3 centimeters. Okay. Which will be, so this is 3 centimeters. This is F1. Now, please watch. This is the tail. And this is the head. But do you notice that they are in the same direction, both east-east? All I need to do is to continue from where I stopped because I am joining the tail of the other one to the head. and I'll be measuring 6 centimeters. F2. Now I told you something. The open tail becomes the tail and the open head becomes the head. Do you notice that this on the end here is open tail? That's where my tail is. And this here becomes the open head. What do I mean? These ones are joined. They are not open. Do you see that? Oh, so what is my resultant? The tail will be here and the head will be there. And that will give me 9 centimeters. Because it's 3 centimeters plus 6 by measurement. That gives me 9 centimeters. Which is my F what? And since 1 centimeter is 1 Newton, it means this is also what? 9 Newtons what? In which direction? In the east. Let me know if that example makes sense to you. What I just did it make sense to you? So sometimes we use construction to do all of those. Talk to me, everybody. Give me a quick feedback. So we join the tail to the head. The open tail forms the tail of the resultant, and the open head forms the head of the other one. I'll do in different directions for you now, just like the one we did. F1 is 3 Newtons east, and F2, let's say 6 Newtons west. Quickly, I want to do that again. Let 1 centimeter. If they don't ask you for construction, then you just need to just draw, estimate. All right, my dear learners, look at this one. This one is interesting. If I start from here and I draw 3 centimeters to the east, it's going to be in that direction. Let's just say that's my 3 centimeters. You've got to measure if they ask you for measurement. Now, 6 Newtons west. Please watch. I'm going to use a different. Remember, we join the tail to the head. I'm supposed to do this. You see, I am supposed to do this. But then you won't see the 3 centimeters anymore. So for clarity, I'll do that. I hope it makes sense. For me to join the head and the tail, it's joined. But so that we can see what's going on, we draw it down. Do you see that? Tail, head, right? Tail and head. I want you to watch something. Do you notice that at this end, they are actually joined? Which one is open? This becomes the open one, open tail, and this becomes what? The open head. So what do I do for my resultant? Tail and head. And it makes sense. If this is 6 centimeters, this will be 3 centimeters. F resultant. So what's my F resultant? 3 Newtons what? Did it make sense to you guys? Tail to head. Tail to head. The tail is joined to the head. Then we look at the open tail and the open head to tell me my resultant vector. Please let me know if we are on the same page. Google. Okay, Chifiwa. So the tail is joined to there. So the reason I'm just drawing it down is because so we can see. Let's do another one, number 3. F1 is 7 Newtons east. F2 is 3 Newtons west. And F3 is 2 Newtons east. We're going to try this together again. Then I'll give you one to try for just 2 minutes. Today I want to look at distance and displacement, the difference between that. Very, very important. Okay. Let's use our construction. So if we're to use construction, you will have to draw, right? But we're just using freehand sketch. Now, guys, always take into cognizance the ones that are in the same direction. It's always easier. F1, 7 Newtons east. Okay, let's start from there. It's going to be the longer one. which is 7 centimeters. Now there's 2 newtons east. Oh, let's just do that one. Okay, 2 newtons east. That will be 2 centimeters. So this becomes my F3. This becomes my F1. Same direction is easy. So you have a tail, you have head, locked on to the tail, and then I have the head. Now what do I have? 3 newtons west, which is 3 centimeters. I have to lock it there. Tail connected to the head and my 3 centimeters. Longer than the 2, but to make it look nice, let's bring it down. Do you see that? Just to make it look visible enough for everyone to see what's going on. Which one is my open tail? You will see that this is my open tail and this is my open head. So what should my resultant be like? The tail from the tail and the head from the head. And what do you think that should be? This one is 3 centimeters. If going to the right, entire thing is 9 centimeters, and going back is 3 centimeters, how many centimeters do we have left? Basic maths, 6, but look at the direction. It's 6 Newton in which direction? In the east direction. Let me know, guys, if what I just explained made sense to you. Open tail and open head. So the open tail will be where I'm going to start my tail from, and the open head will be where my head will be. Give me a thumbs up. I might have missed your responses. All is looking good. Okay. All right, I know you'll be drawing. I'll give you 30 seconds to catch up the notes. Are we ready to move? Chifu, are we ready? Okay. All right, guys. Just going to define 2 things and then we move to motion. Want to quickly define 2 things. Equal vectors and opposite vectors. When are 2 vectors said to be equal? 2 or more vectors are equal if they have the same magnitude and direction. Example. Remember, don't draw a line, it must be an arrow. Five newtons east and another 5 newtons east. F1 and F2. So we can call them equal vectors because they have the same magnitude and direction. This we would use more when we get to grade 11, when we draw a parallelogram of vectors. Okay. Then secondly, we have what you call opposite what? Vectors. Two or more vectors are opposite vectors if they have same magnitude but opposite what? Direction. Take note, the magnitude are the same, e.g. 5 newtons west and it must be opposite. I cannot say 5 newtons west and 5 newtons north. North is not opposite of west. 5 newtons west and east. If I'm using north, then it becomes north and south. I hope we are good. Are we good, everybody? So now we're going to go use all of this that we have learned and move quickly. We're going to move quickly to, this is very, very crucial, distance and displacement. Distance and displacement. We are going to talk about this, but we're going to be using what we call one dimension motion. One dimension motion refers to motion on a straight line. So that's what we are going to focus on. That's why we are using east and west, then north and south. Okay, so we're talking about east goes together with west, or we go to north, let's say east and west, or we go with north and south, one direction, one linear. Okay, so take note of that. That's going to be our foundation. One motion, one dimension. It says it's in a single direction or a straight line. Now, what is distance? Let's talk about distance quickly. Everything I wanted to know about distance. Distance is the length traveled. The length or how far a person has traveled. Distance is the length or how far a person has traveled. Now, it is measured in meters. It is, let's talk about, it is a scalar. We spoke about scalar quantity, so I'm emphasizing measured in meters. So in physics, we always measure in meters and we write M. Please take note, it is a scalar quantity. Emphasis on scalar quantity. Measured in meters. which means since the scalar, it means distance is always positive. We spoke about that a while ago. Example, from point A to B, we could measure the distance and say this is what? 6 meters. It has no direction. It's just 6 meters. No direction. All right, it has no direction. It's just the distance. Please take note. Let's put a keynote there. No direction. So once it has no direction, it is distance. Now I want to talk about displacement. Can I move? Displacement. This is where the work would be. It is the shortest now that changes the whole thing. Distance from the starting point. It refers to location. From the starting point. It is a vector quantity. So we are going deep into our first examples. Hence, it has both, we're repeating that definition, magnitude and direction. Example. So A being my starting point. The question is, where is B? If the distance is 6 meters, where is B? That's the question. What's the displacement? B is 6 meters east of A. Do you see? It's an exact location now. That's the difference between the two. It is an exact location. You'll get to see the difference just in what I'm about to do next. Look at this case study. Point A, point B, point C. Okay, somebody moves from point A to B, and then point B to C, and then they go back to point B. Okay, let's call this 10 meters. 5 meters. Okay, I want you to watch this. If I move from point A to C, let me clean this one. I want to do something. From point A to C, what is my distance? I want us to look at distance and the displacement. Talk to me. What do you think the distance is if this is my start? From point A to C, what do you think the distance would be? Anybody? Quickly, quick responses. What do you think the distance would be? From point A to C. It's very straightforward. This doesn't need rocket science. Don't be scared. $15 what? Remember, with physics, I want to train you. You always write the unit. Emmanuel just said 15. That will be marked wrong. 15 meters. Do we all agree? Give me a thumbs up. If we agree, only Google agrees with you. Or Nuran then decided to give you some comfort and agree with you. But Junior is still saying no, he's not agreeing. And Chifiwa, they say no, you are wrong. Junior, Chifiwa, are you agreeing with Emmanuel? Oh, it took you some time. All right, the distance is 15 meters. It's a scalar. But what is my displacement? When I say displacement, oh guys, talk to me. I wanted to write another word here. Displacement. It means position as well. So what is the position of C from A? Don't forget your compass. You will notice displacement at C would be what? 15 meters east. Does that make sense? That is, I am saying I want to come and meet you at the exact point that you are. You must give me the direction. So I'm not just 15 meters away, because if you say 15 meters, I could be 15 meters north, 15 meters south, 15 meters east, 15 meters southeast, southwest. But my exact position is I am 15 meters what? East of A. Did that make sense to you? Because I'm going somewhere now. I'm going somewhere with this. Now, what about from A to B? No, A to B to C. Or let's make it short. A to C to B. Somebody moves from point A, they go to point C, and then they come back to point B. What is the distance covered? And what is their displacement? I'm going to help you with this one. Oh, thank you. The distance from A to C to B, so it is 10 plus 5 plus 5, 20 meters. I hope that makes sense. 10, 5, 15 plus another 5. But what is my displacement? What is my position? My position is this. That is, where am I? I'm at B now. It is 10 meters east of A. And I want to show you how I'm going to get that by calculation. Because I'm saying, where is my position? It is 10 meters east. Look at my calculation, everybody. My calculation here. Let east be positive. So my displacement would be, so I first went what? 10 meters east, which is positive 10. Then I went another 5. I want to write that on one line. Displacement would be, I first went positive 10 east. Then I went a positive 5 east. But hold on. I turned and I went back now. I am now going backwards, west. And that would be a negative 5. And my answer will be positive 10, which is 10 meters east. Let me know if that makes sense to you. If we can get this out of the way today, we're doing good. Did it make sense? Forward is 10, backward is 5. So it's 10 forward plus, another plus, but I went back, which is now negative. We're good. Because you are going to do the third one for me, and I need everyone to respond to this, because I want to make sure that we are on the same page. So please, from A to C, back to A, what is my distance and what is my displacement? From A to C and back to A, what will be the distance and what will be the displacement? Give me your response. It doesn't matter what your response is, whether it's right or wrong. My job is to make sure. I want to just see where we are. Anybody? 1 minute to answer. Nuran, let's start with you. You are the first on my screen here. Nuran. Nuran, please don't ghost me. Okay, talk to me.
Okay.
Okay. Who's ready? Google, are you ready with your answer? Nuran, I'm giving you 30 seconds. Manuel, are you ready with your answer? Distance is 30 meters, says Emmanuel. Can I get answers from every other person? Let's check. Emmanuel says the displacement is 0. How can that be? Is that correct? Junior, talk to me, please. I want to know what we understand. Guys, please come on. Time. Everybody unmute your mics, please. Nuran, talk to me now. You said 30 seconds.
20.
Which one? The distance?
Yes.
How did you get 20?
Because it's A and Z.
From A to C and to A. So what did you add?
No, we didn't. The one at the bottom, right?
Yes, I'm already done with the other ones, child. A to C to A. Google, please talk to me. Chifua, please talk to me. You guys are finishing my voice now without responding. Junior. Oh, my children. Google Ngumalo.
So I'm still calculating.
What are you calculating, Google? What is the distance?
The displacement.
Okay, what did you get for distance?
30 meters.
Okay. I'll give you 30 seconds. Junior. Oh, Junior says distance is 25. Okay. Junior, do you want to explain how you got your 25 for me? Chifiwa. Nuran, Chifiwa, Junior, I'm waiting. Please, Junior, explain. We only have a few minutes left, 5 minutes left. Junior, how did you get 25? Nuran, you're not talking to me. Chifiwa, I'm not going to talk to you again if you don't talk to me now. Both of you. I'm going to block you on WhatsApp. I'm going to just block you everywhere. Block. I'll wait. When you're ready, you let me know, guys. I need answers.
It's 15.
Sorry, Google, talk to me.
I got 15 for the displacement.
15 for the displacement. All right, Junior says answer is 30 for distance. Google, you got 30 for distance, right?
Yes, sir.
Okay.
No, the displacement is 15.
The what, Nuran?
The displacement
What do you say, 15?
from C to A.
Remember, this person is now back at A, right? From A to C and C back to A. Chifiwa had gone mute on me. She ghosted me, that child. All right, guys. What is my distance? Total distance. You guys are correct. So this guy went 10 and 5, 5 and 10. My total distance is 30 meters. Everybody's good there. Displacement is where I'm having an issue. Let's do something. My displacement is 0. Emmanuel got it right. But how? Let east be positive. So what's my displacement going to be? Check, everybody. From A to B, positive 10, right? Because it's going east. B to C, positive 5. But now, once I go backwards, remember, I am now going west from C back to B. That would be a negative 5. And then B to A, going west, would be a negative 10. And my answer would be 0 meters. Does that make sense? My displacement, my position. My position. Give me a response. Do you understand why we are saying it's 0? Google is lost. Google, unmute yourself for me quickly.
Explain it again.
Definitely I will do. But quickly, tell me what you understood.
Also, I understood that like when we're going backwards, it has to be negative, and like I calculated it positively.
Okay. Remember now that what the west has to be what? Negative, right?
Yes, sir.
Okay. So that's why I said that if my west is negative, let's go back. Let's go back. So we have that, and I have that. So this is A to B to C, which is 10 meters, 5 meters. Now we are saying that east is positive, but then this person goes back this way. So what would this be? A -5 and what? A -10. Do you know why we are putting negative? Google?
Also, -5 and -10 is -15.
-5, yeah. So now let's add. So we're saying, check from A to B plus B to C plus C to B plus B to A. What will that be? What is our A to B? +10, right? Plus
Yes, sir.
+5 plus -5 plus -10. What would that give you?
0.
Because remember, displacement is position. Check something. Displacement means, so you went to school this morning and you came back home. Where are you now? You are at home. It's like you never left to school. Do you understand?
Yes, sir.
It's like you never left, so your displacement is 0. You are back home, and home is the starting point. So you've gone and you've come back, and you are now back home, so your displacement is 0. I don't know if we are on the same page.
I get it, sir.
You get it. Okay, let me just confirm. Nuran, Junior, Chifiwa. You okay, Junior? All right. So please, we must know the difference between distance and displacement. This difference between distance and displacement. Okay, so we'll continue from here. Please don't forget, read the notes before the next lesson. Next lesson is going to be calculations. We are going to deal with speed. We are going to deal with distance again, displacement, acceleration, equations of motion, all in one lesson. So please, I don't want to re-explain displacement and distance again. It must be just well understood now, and the other examples. Okay, that will be the end of our lesson 1. Introduction to vectors and scalars. I hope we are good. The grade 11s are beginning to give me a bombastic side eye. Are we good? All right, Chifiwa, thank you for not talking to me, but it's okay. My heart is broken, but I'll mend it. All right. Yeah, you're laughing. Okay. Have a lovely evening, everybody. My grade 10s. Goodbye.